solutions from exercise 3.1 from the chapter 3, linear equations. So in the first question, they're asking us to form a pair of linear equations in the following problems and find their solutions graphically. So in the first question, they've said that 10 students from class 10 took part in a mathematics quiz. If the number of girls is 4 more than the number of boys, we need to find the number of boys and girls who took part in the quiz. So they've said that 10 students in total participate in the mathematics quiz. And we're going to assume that the girls is X and the number of boys is Y. So they said that the number of girls is 4 more the number of boys, and the total number of students, meaning X plus Y, is equal to 10. And we need to find the values of X and Y graphically. So we can find the values of X and Y graphically by using the tabular column to find out different values of X and Y to plot on the graph. And when we connect all of the points on the graph, it'll form a line. And the points where both of these intersect is the solution for the equation. So first, let's take this. And let's write it as X minus Y is equal to 4. And we're going to write the values of X and Y here. So if you take the value of X as, for example, let's say if we take it as 5, then the value of Y will be 1. And if we take the value, if we substitute the value of X as 4, for example, then the value of Y will be 0. And if we take the value of X as 6, then the Y value will be 2. And if we take the value of X as 7, we'll get the value of Y as 3. We can continue doing this, but we'll stop here. So similarly, in the second equation, X plus Y is equal to 10, we're going to take the values of X and Y, we're going to substitute any value of X, and we're going to find the values of Y. So if we take the value of X as 4, then the value of Y will be 6. If we take the value of X as 6, then we'll get the value of Y as 4. If we take the value of X as 7, we'll get the value of Y as 3. Now we will notice that 7, 3 is common in both. That means 7, 3 is the intersection point between both of the lines. X is equal to 4 plus Y and X plus Y is equal to 10. So that means that 7, 3 would be the answer to the given question, meaning X, the value of X would be 7 and the value of Y would be 3. So this is the point of intersection between both the lines, meaning that this would be the solution. And the points that we found out here, 5, 1, 4, 0, 6, 2, all of them when plotted on a graph will form a line when we join them together. Similarly, 4, 6, 6, 4, 7, 3 will form a line on the graph. And the points of intersection between those two lines is 7, 3, so that is the answer to the first question. In the second question, they've given that 5 pencils and 7 pens together cost 50 rupees, whereas 7 pencils and 5 pens together cost 46 rupees. We need to find the cost of 1 pencil and that of 1 pen. So let us assume that the cost of 1 pencil is X and the cost of 1 pen is Y. And they said that 5 pencils and 7 pens together cost 50, so 5x plus 7y is equal to 50, and 7 pencils and 5 pens together cost 46, so 7x plus 5y is equal to 46. So now let us write the tabular column for both equations, X and Y. So let us assume the value of X as 3. So if we take the value of X as 3, then the value of Y would be 5. Similarly, in the second equation, if we take the value of X as 3, the value of Y is also going to be 5. So that means we can go on and substitute the values of X and Y for different values and find different points on the graph. But since we already know that both 3 and 5 are common solutions of X and Y for both of the equations, that means this is the point of intersection between both the lines. So that means the point 3, y is the solution for the given two equations, and the value of X is equal to 3 and the value of Y is equal to 5. In the second equation, they're asking us on comparing the ratios of a1 by a2, b1 by b2, and c1 by c2, we need to find out whether the lines representing the following pairs of linear equations intersect at a point, are parallel, or coincident. We know that if a1 by a2 is not equal to b1 by b2, then we will have a unique solution. If a1 by a2 is equal to b1 by b2 and is equal to c1 by c2, then we will have a coincident line with infinite solutions. And if a1 by a2 is equal to b1 by b2, but it is not equal to c1 by c2, then it will be a parallel line with no solutions. So, in the first question, a1 is 5, a2 is 7, b1 is minus 4, b2 is 6 plus 6, and c1 is 8, and c2 is negative 9. So 5 by 7 is not equal to negative 4 over 6. So that means that this equation has a unique solution. In the second question, they've given 9x plus 3y plus 12 is equal to 0, and 18x plus 6y plus 24 is equal to 0. So a1 is 9, a2 is 18, b1 is 3, b2 is 6, c1 is 12, and c2 is 24. So 9 by 18 is equal to 1 by 2, 3 by 6 is equal to 1 by 2, and 12 by 24 is equal to 1 by 2. So all of them are equal, suggesting that this pair of equations have infinite solutions, and they are coincident. In the third question, they've given 6x minus 3y plus 10 and 2x minus y plus 9 is equal to 0. So a1 is 6, a2 is 2, b1 is negative 3, and b2 is negative 1, c1 is 10, and c2 is 9. So 6 by 2 is basically 3 by 1, and negative 3 over negative 1 is positive 3. So this is equal, but negative 3 over negative 1 is not equal to 10 by 9. So that means that this pair of equations have no solution, and they are parallel lines. In the third question, they're saying that on comparing the ratios of a1 by a2, b1 by b2, and c1 by c2, we need to find out whether the following pair of linear equations are consistent or inconsistent. So in the first question, they've given 3x plus 2y is equal to 5, and 2x minus 3y is equal to 7. Before moving to the questions, we know that if the pair of equations are consistent, that means it's either a coincident line or they have a unique solution, meaning they intersect at one point, and it is inconsistent if the given equations represent a parallel lines or it has no solution. So in the first question, a1 is 3 and a2 is 2, which is not equal to b1, which is 2, and b2, which is negative 3. So we can say that they have a unique solution, and hence they are consistent. In the second question, they've given 2x minus 3y is equal to 8, and 4x minus 6y is equal to 9. So a1 is 2, a2 is 4, which is equal to negative 3 over negative 6, but is not equal to 8 over 9. So 1 by 2 is equal to 1 by 2, because negative 3 over negative 6 can be simplified and written as 1 by 2. So that means, since it's a1 by a2 is equal to b1 by b2, but it's not equal to c1 by c2, we can say that this pair of equations have are inconsistent because they represent parallel lines. In the third question, they've given 3 by 2x plus 5 by 3y is equal to 7, and 9x minus 10y is equal to 14. So we're going to simplify the first equation because there's different denominators, and it'll be much easier to solve if we cancel the denominators. So in order to do that, we're going to make sure that 3 by 2 and 5 by 3 have the same denominator, and we're going to bring the denominator over to this side. So we'll get 9x plus 10y by 6, which is equal to 7, and 9x plus 10y is equal to 42. So this would be the first equation, and 9x minus 10y is equal to 14 would be our second equation. So A1 is 9, A2 is also 9, which is not equal to positive 10 over negative 10. So since A1 by A2 is not equal to B1 by B2, we can say that it is consistent and it has a unique solution. So in the fourth question, they've given 5x minus 3y is equal to 11, and negative 10x plus 6y is equal to negative 22. So A1 is 5, A2 is negative 10, B1 is negative 3, and B2 is positive 6, C1 is 11, and C2 is negative 22. So 5 over negative 10 can be written as negative 1 over 2, which is equal to negative 1 over 2, and 11 by negative 22 is also equal to negative 1 by 2. Since all A1 by A2 is equal to B1 by B2 is equal to C1 by C2, then we can say that the pair of equations have infinite solutions and are coincident. In the fifth question, they've given 4 by 3x plus 2y is equal to 8, and 2x plus 3y is equal to 12. So we're going to make sure that all of them have the same denominator so that we can bring it over to this side, so it'll be much easier for us to calculate. So in order to make sure that 2y also has a denominator of 3, we're going to multiply the numerator and the denominator with 3. So you'll get 4x plus 6y over 3 is equal to 8, and 4x plus 6y is equal to 24, which is the first equation, and the second equation is 2x plus 3y is equal to 12. So A1 is 4, A2 is 2, B1 is 6, and B2 is 3, which is equal to C1, which is 24, and C2 is 12. 4 over 2 is 2, 6 over 3 is also 2, and 24 over 12 is also 2. Since all of A1 by A2, B1 by B2, and C1 by C2 are all equal, we can say that it has infinite solutions and are hence coincident. In the fourth question, they're asking us which of the following pairs of linear equations are consistent or inconsistent, and if consistent, we need to obtain the solution graphically. So the first question, they've given x plus y is equal to 5, and 2x plus 2y is equal to 10. So 2x plus 2y is equal to 10 can be simplified as x plus y is equal to 10. So A1 by A2 is equal to B1 by B2 and C1 by C2. So both of these equations have infinitely many solutions. Since both of the equations are same, we're just going to find the tabular column for one equation. So if we take the value of x as 1, the value of y would be 4. If we take the value of x as 2, then the value of y would be 3. And if we take the value of x as 3, then the value of y would be 2. And we can continue going on substituting the values of x. So all the points 1, 4, 2, 3, 3, 2 will all lie on the same line. And we can find infinitely many points for this equation. And these two pair of equations are consistent and have infinite solutions. In the second question, they've given x minus y is equal to 8 and 3x minus 3y is equal to 16. So 3x minus 3y can be simplified as x minus y is equal to 6, and a1, which is 1, a2, which is 1, is equal to b1 and b2, but it is not equal to 8 over 6. So we can say that a1 by a2 is equal to b1 by b2, but not equal to c1 by c2. Hence, these pair of equations have no solution and is inconsistent. In the third question, they've given 2x plus y minus 6 is equal to 0, and 4x minus 2y minus 4 is equal to 0. So this equation can be simplified as 2x minus y minus 2 is equal to 0. So a1, which is 2 over a2, which is 2, is not equal to 1 over negative 1. So we can say that this pair of equations have a unique solution. So for the first equation, 2x plus y minus 6 is equal to 0, we're going to find the tabular column values for x and y. So if we take the value of x as 0, then the value of y would be 6, and if we take the value of x to be 3, then the value of y would be 0. Similarly, for the second equation, we are going to find second equation, which is 4x minus 2y minus 4 is equal to 0. If we take the value of x as 0, then we'll get minus 2. And if we take the value of x as 1, then we'll get the value of y as 0. If we take the value of x as 2, then we'll get the value of y as 2. Similarly, in this equation, the first one, 2x plus y minus 6 is equal to 0. If we take the value of x as 2, then the value of y will also be 2. So 2, 2 is the intersecting point between the lines of 2x plus y minus 6 and 4x minus 2y minus 4. So that means 2, 2 would be the solution for equation 3. In the fourth question, they've given 2x minus 2y minus 2 is equal to 0, and 4x minus 4y minus 5 is equal to 0. So a1, the value of a1 is 2, value of a2 is 4, which is equal to 2 over negative 4, but it is not equal to negative 2 over negative 5. So since a1 by a2 is equal to b1 by b2, we can say that, but it is not equal to c1 by c2, we can say that there are no solutions and it is inconsistent. In the fifth question, they've given that the half the perimeter of a rectangular garden whose length is 4 more than its width is 36 meters. We need to find the dimension of the garden. So we're going to assume length is x and breadth is y. And half perimeter is basically half times 2 into L plus B, which is the perimeter of a rectangle, which we'll be able to cancel both the 2's, which will leave us with L plus B is equal to half the perimeter. And since we've assumed L to be x and B to be y, x plus y is equal to half perimeter. And they've given that the half perimeter of the rectangle is x plus y, which is equal to 36. And they've also given that the length is 4 more than its breadth. So x is equal to 4 plus y. So we have two equations, x is equal to 4 plus y, and x plus y is equal to 6. So we need to solve for x and y. So since x is already represented in the terms of y, we're going to substitute the values of x in terms of y in the second equation, x plus y is equal to 36, in order to find the value of y. And after finding the value of y, we're going to substitute that in either of the equations to solve for the value of y. Solve for the value of x. So since x is equal to 4 plus y, 4 plus y plus y is equal to 36, and 4 plus 2y is equal to 36, and 2y is equal to 32, and y is equal to 16. And now, since we found out the value of y, which is 16, we're going to substitute that in x plus y. X is equal to 4 plus y. So x is equal to 4 plus y, which is 16, and x is equal to 20. So x is equal to 20 and y is equal to 16. So x, which the length is equal to 20, and y is equal to 16 meters. In the sixth question, they've asked us to find, with the given linear equation 2x plus 3y minus 8 is equal to 0, we need to write another linear equation in two variables such that the geometrical representation of the pair so formed is, first we need to find another equation which is intersecting. So if both equations are intersecting, it means a1 by a2 is not equal to b1 by b2. And there are many different variations of equations that we can form, but for this case, we can take the equation to be x plus y plus 1 is equal to 0, and in order to check if these two equations are intersecting, a1, which is 2 over 1, is not equal to 3 over 1. So a1 by a2 is not equal to b1 by b2. Secondly, they're asking us to find an equation which is parallel. So if it is parallel, that means a1 by a2 is equal to b1 by b2, but it is not equal to c1 by c2. One such equation can be 4x plus 6y plus 1 is equal to 0. Thirdly, they're asking us to find an equation in which the lines are coincident. And if it is coincident, that means a1 by a2 is equal to b1 by b2 and is equal to c1 by c2. And one such equation can be 4x plus 6y minus 16 is equal to 0. In the seventh question, they're asking us to draw the graphs of the equation x minus y plus 1 is equal to 0 and 3x plus y minus 12 is equal to 0, and determine the coordinates of the vertices of the triangles formed by the three lines and the x-axis, and shade the triangular region. So in order to draw the lines for both of the equations, we need to find points of x and y which satisfy the given equation. So we need to find x and different values of x and y for both the equations and then plot it on the graph. So the first equation can be written as x minus y is equal to negative 1. And if we take the values of x as 0, then the value of y would be 1. And if we take the value of x as negative 1, then you'll get the value of y as 0. Similarly, the second equation can be written as 3x plus 2y is equal to 12. And when we substitute the value of x as 0, then we'll get the value of y is 6. And if we substitute the value of y to be 4, then the value of y would be 0. And now we need to plot it on the graph. So when we plot the points 0, 1 on the graph, 0, 1 will lie here, negative 1, 0 will be over here, 0, 6 would be here, and 4, 0 would lie here. So when we connect 0, 6 and 4, 0, we will get the line as such. And when we connect the lines minus 0, 1 and negative 1, 0, we will get the line over here. So the point of intersection would be 2, 3, which is over here. And in the question, they're asking us to find the coordinates of the vertices of the triangle formed. So the vertices of the triangle would be 2, 3, which is here, and negative 1, 0, and 4, 0. And they're asking us to shade the region of the shade the triangular region. So this is what we have to do.